Okay, solving equations. These are linear equations. Very important that we do this systematically. So, for example, we have x plus 5 is equal to 9. Okay. To solve means we need to find the value of x that makes that true. What plus 5 makes 9? Well, we know what x plus 5 is. We want to know what x is, what the value of it is. So we're going to take away this 5. But whatever you do to one side of the equation, you must do to the opposite side. So I'm also going to take away 5 here. So this is perfectly legal because we have two things that are equal, and we did the same thing to both sides. Therefore, they're still equal. The reason we chose subtract is 5 minus 5 is 0. Okay, so I don't have to say x plus 0 because it's just x. It gets rid of it. In this sense, it cancels it out. On the other side, we have 4. So x equals 4 is what we call the solution. It would make it true if you were to plug 4 back into the equation. A similar equation. Let's suppose we have 5x is equal to negative 30. Okay, now again, we want to get x by itself. We've got to find a way to get rid of this 5 again. This time it's 5 times. Well, subtracting 5 is not going to do it because 5 times x and then subtract 5 is not the same thing as x. So I need to come up with something that sort of undoes multiplication. And that something would be division. So I'm going to divide by 5 on both sides. 5 divided by 5 is 1. And again, that crosses out this time. Even though it's the number 1, the reason it crosses out is, well, just like before, x plus 0 is still x. Well, 1 times x is still x. Okay, so it still goes away. So if they multiply, we want to divide. All right, so negative 30 divided by 5 would be negative 6. Just be careful with your operations there. All right, so a third example. X divided by 4 is equal to 8. Well, we don't want to know what x divided by 4 is. We want to know what x is. So what's the opposite of dividing? We're going to multiply to both sides. I'm going to multiply both sides here by 4. Remember, if I do it to one side, I must do it to the other. We don't really care to do it to the right-hand side. That doesn't help us, but we just have to. If we do it to the left-hand side, you've got to do it to the right-hand side as well. Just like in number 2 where we had 5 on top and bottom, here we sort of have 4 on top and bottom, and the 4's cancel. Okay, so my solution here is x equals 32. Okay, so those are one-step equations. I didn't show the one where you subtract. I'll do that next. I want to go ahead and go to a two-step equation. We'll do a couple examples here. A two-step equation, this will be our fourth example, generally has this setup. 5x minus 7 is equal to 43. So there's 5 again. All right. Again, our goal is to figure out what x is. We have 5 and 7 with the x. And you may know the order of operations, but understand that the order of operations doesn't apply to solving equations. It applies when you're evaluating an expression, and that may not matter much to you. But the reason I say that is there's no rule here that says I have to multiply before I add. There's no rule here. I can do whatever I want to whatever I want as long as I do it to both sides, okay, in an equation. So the reason I say that, you don't want to divide by 5 here. You could, but when you divide this by 5, you'll also divide that by 5 and make some messy fraction, and that by 5. We want to avoid that. So it's easier to get rid of the 7. So you want to do the opposite of operation here, which would be adding 7. Again, which is fine as long as you do it to both sides. Generally, this is not a perfect rule, but often when you're solving equations, you look at the thing farthest away from x and deal with it first. especially for these linear equations. They're going to cross out. So we have 5x is equal to 50. That's 43 plus 7. And that makes it a one-step equation, which we've already covered. If they multiply, I say they, if the problem multiplies, we're going to counteract that by dividing. 50 divided by 5 is 10. And we'll look at how to check that later. I'll tell you briefly, you just take the 10 and plug it in there and use the order of operations on this side to see if it works. So we'll do that in a bit. We'll erase this, do one more example. Let's say we have x over negative 6 plus 3 is equal to negative 3. Okay. Same deal. X is right here. The 3 is farther away. Let's deal with the 3 first. I'm going to subtract it. Again, canceling. X over negative 6 is equal to negative 6. And use caution when you're working with sign numbers. Negative 3 minus 3 is negative 6. It's not 0. Negative 6 plus negative 3 would be negative 3 plus 3, not negative 3, would be 0. I like the idea of you doing it in your head, but I would, if I'm on a quiz or test and I have a calculator, I would use it to make sure I'm right there. So make sure you have that as negative 6. And then we're going to multiply by negative 6, just like before, putting one on top and one on bottom to make them cancel. And knowing here that negative 6 times negative 6 is 36. Again, it's called my solution because it's going to make the equation true. Solve an equation.